Hi everyone, welcome back to our channel. I hope you and your family members are doing good because that is the most important thing, and for rest we are here to talk. And we are doing the very first topic, which is array, and inside the array we have seen four different types of pattern. Two pointer, sliding window, prefix sum and cadence. And in today's video we are going to cover the second question, which is maximum consecutive sum from the sliding window. So here is our problem, name maximum consecutive ones. Let's read the problem statement. It says given an binary array nums, you have to return the maximum number of consecutive ones in the array. Maximum number of consecutive ones. So if you see the input array, it is having 1, 1. After that it is having 0. So what is the maximum consecutive 1 till now? 2. Okay. After 0 means 0 we cannot include. After 0 again we will start counting, and this is 1, 1, 1. So 3 times consecutive 1 we are having. So in the output we have to return 3 here. The first 2 digits or the last 3 digits are consecutive ones. Yes. And the maximum number of consecutive ones is 3. Okay, so task is very simple. You have to continuously look for the consecutive ones. If any time the next number becomes 0, you have to stop. Something like that. Okay. Let's see the constraint. Constraint says the number of length can vary till 10 power 5. 10 power 5. And we know beyond 10 power 8 we cannot run. So hence in 10 power 5 case, if we will do the brute force approach with n square time complexity, it will be 10 power 10. And that will give you TLE, correct? So hence in this case we need to optimize our code. But before optimize, let's see the brute force approach for this code. So here is our input array. We will be given consecutive ones, in between few zeros, and then again consecutive ones. You have to calculate all such consecutive ones and then return the maximum out of it. Okay, let's see how can we think the brute force approach in this case. So suppose we will start our I pointer from the 0th index. So now if we have started our I from the 0th index, what is our next task? I will check, hey, is this 1? What I'll check? I'll ask if my ith value is 1. Suppose yes, it is 1. Now I will move to next. Is this 1? Yes. Is this 1? Yes. So from a particular I index, I will check every element until it hits 0. Correct? So for the brute force approach, you will run another J loop starting from the same index I, and for I is equal to 0, I will run a J loop until it hits the 0. Correct? And I will calculate the length. How I can calculate the length? So length will be nothing but wherever my J will be minus I in this case. So if you will see, suppose I will start my J from here. Correct? So after that I will move to next. Correct? Then it is 1. Yes. Again. Is it 1? Yes. Again. Is it 0? No. But J is here now. And what is the length between this? If you will see, indexing. So this is 0 base, 1, 2, 3. And I want 3 length only. So that is why I will do J minus I for my length. Although for length we always do J minus I plus 1. But in this case, if you see, the J which index is pointing to means the location which J index is pointing to is invalid. Means we are not supposed to count this J now. So even if you write this, after that you are not supposed to count one last index where J is pointing to. So you will subtract 1. So hence we can say directly J minus I for the length calculation. Correct? Okay. Now first time you have saved key. Okay, my maximum answer will be what? 3 you have calculated. Next time again you will move your I towards the next index, and now again you will start your J from the same I index. Correct? This is what in brute force approach you will think. Okay. Again now I will be at this. So you will start your J, this and this. Again it will hit 0. Yes. Now what is the length? 2. Correct? So now you will check and update key 2 is maximum or 3 is maximum. Okay. But don't you think, if you'll see here, okay, for every I you are running the J loop. Correct? So I will be 0, you are running the J loop for entire n only. What if there will be no 0? In that case, so you will end up running the J for the entire length. How? Let's see. Suppose we have all ones. 5 ones, suppose. Okay, so I will put my first I index at 0 index, and I will start my J from 0 index, and for I is equal to 0 I will run my J to next point. Again, is it 1? Yes. Again move next. Is it 1? Yes. Again move next. Is it 1? Yes. Again move next. Is it 1? Yes. So you will calculate the 5 length. Correct? This is what you will do. Now next time you will move your I index towards the next, correct? Yes. And now again you will start your j from which location? I location. Again you will move your j for the next one. This. Correct? So in this case, you will run j for every I. But don't you think कि the maximum length will be from I is equal to 0 index? Because if you will calculate from I is equal to 0, you will get 5 length. For the next time, when you will calculate from I is equal to 1, obviously it will be smaller length. Again, if you will next time you will calculate from I is equal to 2, it will be of smaller length. So we saw कि okay, if we will run by 2 for loops, then to our code will definitely run. Okay, but that will be brute force approach, and along with the brute force we are actually doing unnecessary operations. What unnecessary? Here you knew कि from I is equal to 0 to j fourth index we have the maximum length. Now you are moving your I to next index. Again you are starting your j from the same index to calculate the next length, assuming कि we might get the maximum length. But in this case, it is guaranteed you will never get the maximum length. Correct? So how your brute force code will look like? Let's see. So you are actually saying कि I will start my for loop I is equal to 0 to I less than n. Correct? And I plus plus. Correct. Now you are saying you will start your j loop. Int j is equal to 0, j less than n, j plus plus. Kind of, or you can consider this inside the while loop also. Okay. Now I am saying if my array of I is equal to 0. If this is the case, what is my task? What is my task? I want to break that j loop. I don't want my j to move ahead, correct? If j hits 0, I don't want my j to move further. So basically I have to break this second for loop for j, correct? So what I will do? I will break. But one more thing you have to do before breaking. What? Before breaking, you have to calculate the length and save it in the maximum answer. Correct? So what I will do? Length will be nothing but what? J minus I. Correct? J minus I. And we have to update with maximum answer also. So basically, before this break, what we will do? We will update in the maximum. So with max answer, I will say, hey, update whatever is the maximum answer. So my previous answer is maximum or this length is maximum. So whatever is maximum will be updated in the maximum answer. Correct? Now next time again your I will start from first index and again you will j run for the entire until it hits 0. Next time it will get only 2 length. Again next time I will start from second index, j will also start from second index till third until it hits 0. In this case the length will be 1. Correct? Now next time again you will start your I from fourth index 0, 1, 2, 3. Sorry, third index. Correct? Now again for third index also j will start from third and it will check no, it is 0. So length will be nothing but j minus I, both are pointing to third index, so length will be 0 only, so maximum. So don't you think we are unnecessarily doing all this? When from leftmost I to the j position, when it first time it hit 0, that was the maximum length 3. Correct? So in this case, even this code will run, but it will give you TLE. Why? Because in total it is taking O of n square time complexity to run. Correct? Because for every I you are running j for n times. You will say yes, I am breaking it in between when it will hit 0. But what if in the entire array you have all ones? Then to it won't break now. So for every I it will run entire j for 5 times, like length of like array length. Correct? So O of n for this first for loop and O of n for the second for loop. O of n square time complexity. And you just saw in the constraint that the time complexity constraint is 10 power 5. We cannot go for O of n square. So we have to optimize the code here. And you know, whenever we talk about the optimization, we always talk about the patterns we have discussed in our array. And those patterns were 2 pointers, sliding window, prefix sum, and cadence algorithm. And you know that these sliding window, prefix sum and cadence algorithm we use whenever we have to talk about the continuous subarray. And we have to care about the elements inside the subarray also. Correct? But when we have to talk about 2 different points, then we go with the 2 pointer approach. But here if you see, we have to do or we have to check everything inside it. Correct? Basically we have to go for the length only. But we want the continuous subarray. means when 0 hit, we have to leave this subarray and we have to start the another subarray. Correct? Yes. So that is why it can be sliding window, prefix sum or cadence, but for sure not 2-pointer. Now let's see what is prefix sum. Prefix sum we need whenever we want the continuous subarray but summation. Here we don't need summation. Yes. So hence we can cancel prefix sum. Cadence algorithm we use whenever we need the subarray summation, but negative number also lies here. And if you will check in the constraint, it says ki the number will be either 0 or 1. So hence we don't have to take care of the negative number, means no cadence algorithm. So hence we can blindly go with the sliding window, and all these patterns we have already discussed in our very first lecture of the video of the arrays playlist, which you can find the link somewhere above. And if you have not watched it out, I'll definitely recommend you to go and check and learn the patterns first and then come on to the question here. So now let's discuss the optimize approach. Optimize approach will be, you are starting from I is equal to 0, correct? And till j you run until it hits 0 and you have calculated the maximum length, correct? But here you know ki if you are starting from I is equal to 0 and you know ki always your j will stop here for sure. So what do you think? You will get maximum length with I at leftmost position or I towards the next position? For sure means if your I, these are the numbers, correct? So if your I is equal to at 0 and you know always your j will stop here. So the maximum length of this continuous 1 you will get from I is equal to 0 instead of I is equal to 1 or I is equal to 2. Yes or no? Of course, yes, correct. So that's what sliding window says, ki you start from the starting index and when you hit this current 0 now, instead of moving ahead, why not to directly start from the next pointer, like after 0? Correct? So after 0 we will start. So we will neglect the unnecessarily length calculation which we were doing earlier because of the j loop. Correct? So basically we will simply start our current pointer or j pointer. Suppose we will start our j pointer and we will check ki if my array of j is 1, we will simply count the length. Okay? Count the length is nothing but we will increment our counter. So I will make a current count variable somewhere here with 0. Okay, and for j I will run a while loop ki while j hits n. So what's my task? I'll check if my array of j is equal to 1. If it is equal to 1, what is my task? I'll simply do j plus plus. Why? Because see, here it is equal to 1, correct? So I will do simply j plus plus. But along with j plus plus, I will do increment my current count also. So what I will do? Along with j plus plus, I will do current count plus plus also. Correct? Yes, I'll do that. Okay. Now, suppose in else case what I will do? Let's see. So after this point, again it will move to next point. It will say yes, I am still 1. So current count will be 3. Again it will hit 0. Current count is still 3, but we have hit 0. So we will fall in the else case and current count is 3. So what do you think? What is my task? My task is to update in my maximum answer, correct? So what I'll do? I will update my max answer. So max answer is equal to math.max with previous maximum answer or the current count is maximum. What is maximum? Okay. I will update this my current count. Okay. Now if this is the case, what do you think? Till now my current count was 3. Correct? Now next time my j plus plus will move. Okay. So j plus plus again in this case also. Correct? So we saw okay j plus plus is common in both if and else case. So we can put this outside the if else also. So after coming out of the else loop we will simply write j plus plus because for both if and else case I want my j plus plus to run. Okay. So in the else case I updated my maximum current answer. Correct? I updated my current count. So what do you think? After this 0, you want the same current count 3 to be added next time or you want to update your current count with 0? Yes, 0. Why? Because now again you want to start your fresh count for the continuous one. Correct? So in the else case you will simply do current count update with 0. Correct? And after coming of the while loop we can simply return our max answer here. Yes or no? Yes. So you saw ki j plus plus you have to do in both if and else case. So that's why you can take care instead of while loop, you can take care in the for loop as well. Correct? Because our pointer j, when it moves with the same speed, whether no matter if case or else case. So basically instead of while loop, you can go with for loop also. Okay, but the logic in this case will be same. If it is 1, keep on counting the current length, continuous length, and if it is 0, stop there, update the length you have counted till now, and again refresh your current count with 0. So in this case, what is the time complexity? Nothing but how many times while loop or for loop has run. That is nothing but n. So in total you have used O of n time complexity, and hence that is the most optimized solution compared to the previous one where it was taking O of n square. Here it will take only O of n, and we have neglected all the unnecessary calculation of length as well. Okay, so with this approach we can come onto the screen and let's submit the code for this. So basically what we want to calculate our maximum answer and current count. So basically we will initialize with 0 and our current count also. Current count will take care of the current length. Okay, now I want to run a for loop for I or j. Suppose j I will initialize with 0 and j will run till less than n, and n is nothing but nums dot length. I will run till j less than n and I will do j plus plus. But wait, I don't have initialized my n, so I will write int n is equal to nothing but nums dot length. Correct. Now inside this, what's my task? My task is to check if it is equal to 1 or not. So if my nums of j is equal to 1, what's my task? Simple. What's my task? What I'll do? I'll simply do current count plus plus. Correct. I'll simply do current count plus plus. In else case, what's my task? In else case, my task is to update my max answer. Basically max count. So max count I will update with math dot max. What's the maximum answer? Maximum count is the maximum answer, or my current count is the maximum answer here. Okay, so I will update this. After update, my task is to start my current count with the new refreshed value 0. Correct? Yes. Yes. So after coming off the while loop, we can simply return our current count. Yes. But let's come onto the screen. So if you see here, first time it will check inside the while loop or for loop, it will check array of j is equal to 1, yes, 1, yes, 1, yes. When it hit 0, then only you updated the length. Na? See, in the else case you updated the length. But in the next case, even though you will count 0, 1, 2, 3, 4, 4 length you will count in the if case. But you will never fall in the else case again. But why? Because you will end up in the while loop or for loop when j will go out of index, because j has not found 0, and else case will only run when j will hit 0. So when you will come outside this, this is the maximum answer you have updated till now. This maximum 4 answer you have not even checked it is maximum or not. Okay, so after coming off the while loop, before returning, I can simply check that this current count which we have not updated, let's check if this is a maximum or not. If this is maximum, return that. So basically, while returning our current count, our task is to, I meant the max count here. Okay, so before returning our max count, we know that we have not updated this, basically the last one current count. So instead of returning this, I will check which is maximum. Which is maximum? The maximum count is maximum, or the current count which we have not updated last time. Correct? This is maximum. Which is maximum? We will return that. Okay, so it has run. Now let's submit this, and hence as you can see 98%, so means it was the most optimized solution. So this was our Java code. I hope you understood why we updated the last time, because the last else case for last current count, else case has not run. That's why it is very important to update this before returning this. Okay, so this was our Java code, and here with the same logic you can find our Python code if you are from Python background, and here you will get your C++ code with the same logic. So whether you are from C++, Java or Python, anyhow logic will be same, code language will matter, and hence I have provided all the different codes for you so that it will be helpful for all the different language backgrounds. So that's it. With this we can go and mark the next question in the sliding window, which is maximum consecutive ones. Yes, and I hope you are following this Rising Brain sheet, which is nothing but pattern wise DSS sheet. And if you don't have the link, you can find the links from the description below. And if you want to connect with me on Instagram, LinkedIn, Twitter, you can find all the social media links in the description below. So I hope this video was helpful. If you think any other kind of feedback that will improve our lectures, then don't hesitate to mention in the comment section. I'll definitely check it out. And apart from this, if you really feel that video is really helpful, then don't hesitate to share with your friends, and do give your like and comment and subscription as well, because that gives me more motivation to make more videos. That's it for the video. I hope you learned something new from this video. Let's meet in another video with some more interesting question and topic. Till then, keep learning, take care of yourself and your family.